Today we are going to the last topic, and this is last period, last class to complete the numerical analysis. So let us start the uh, this class. This class we have to study the numerical integration. Then what is the numerical integration means? The process of obtaining the approximate value of the definite integral. That is, definite integral we consider I is equal to integral a to b f of x dx. Without actually integrating the function, but only using the values of y and use some points of x equally spaced in between the limits a into b. It is called the numerical integration. And after numerical integration, the process we apply to function of a single variable is known as a quadrature. From this quadrature, we know that how to find the quadrature formula. Now consider the integral I is equal to integral a to b f of x dx, and like take the values of x naught is x values are like this: x naught plus h, x naught plus 2h, then x naught plus 3h, then y of x, if x naught, y of x naught is y naught, y of x1 is y1, y of x2 is y2, and so on like this. And all the values of y of x naught, y of x1, y of x2 substitute in the main integral. Main integral is our I is equal to integral a to b f of x dx. Then, and using the Newton's Gregory interpolation formula, we know that very well. What is f of x? F of x is equal to y naught plus p delta y naught plus p minus 1 2 factorial delta square y naught plus and so on dx. From this we will get this quadrature formula. I is equals to integral over limit x naught to x naught plus nh f of x dx. F of x, this h how will get it means we know that very well. Xn is equals to x is equal to x naught plus ph, then p is equal to x minus x naught by h. That means if x is equal to x naught plus nh, then this means that p is equals to n. So then we'll get here that h is here, n y naught plus n square by 2 delta y naught plus 1 by 2 n cube by 3 minus n square by 2 delta square y naught plus 1 by 6 n to the power of 4 by 4 minus n cube n square delta cube y naught plus and so on. Call this is equation number 3. The equation 3 is known as the Newton's Cotes quadrature formula, or generally it is known as the quadrature formula. From this general quadrature formula, we can derive the various special formulas giving different values of n. Now we introduce for quadrature formula, namely we can divided it is the different integrals, trapezoidal rule, Simpson 1/3 rule, Simpson 3/8 rule, like this. These are all rules we solve from using the quadrature formula. So first let us trapezoidal rule. Trapezoidal rule, put n is equal to 1 in the equation 3. Wherever n is there, put n is equal to 1. We get, here is also in. In is equal to integral over limit x naught to x naught plus n is equal to 1, x naught to x naught plus h, n is 1 here. I told no, n is 1. Instead of nh, we are writing the upper limit x naught plus h. F of x ds, h as it is, n is 1. Wherever there is an equation n, we substitute 1, we get like this: y naught plus 1 by 2 delta y naught. Then we consider only two terms, h into y naught plus 1 by 2 as it is, delta y naught. We studied already. Delta y naught, how we write? y1 minus y2. That is the first difference. That is the forward difference, first value. y1 minus y2. Then here simplify this. 1 by 2 is multiplied by y1. 1 by 2 y1 minus 1 by y2. minus 1 by 2 y naught minus 1 by 2 y naught plus y naught. We'll get plus y naught. So here taken plus is common. We write y naught plus y1. Similarly, we can find n is equal to 2 in equation 3. We get I2 is equal to integral over the limit x naught plus h to x naught plus 2h. Then here h f of x dx h by 2 y1 plus y2. Here we come to the clearly we know that I1 is h by 2 y0 plus y1. I2 written as h by 2 y1 plus y2. I3 is written as h by 2 y2 plus y3 and so on. Like we can write the general term, right, integral over the limit x naught plus n minus 3 into h x naught plus nh f of x dx equals to I3 is equals to, we can write In is equals to f of x dx h by 2 y of n minus 1 yn. Adding these n integrals we obtain. Adding these integral means I1, I2, I3, In. We'll get In is equals to integral over the limit x naught plus n minus 1 into h to x naught plus n into h. So f of x dx h by 2 is equal to yn minus 1 plus yn. We write general term. Here y1 plus y2, y1 plus y2, y2 plus y3. The general term is yn minus 1, yn minus 1 plus yn. Then adding these terms, we'll get x naught integral over limit x naught to x naught plus nh f of x h by 2 y naught plus y1 h by 2 y1 plus y2 then plus h by 2 yn minus 1 plus yn. What we are writing means here we are substituting delta y naught value, delta square y naught value, delta cube y naught value, then lastly delta to the power of n y naught. Those are called the differences of the forward difference, first to second, third and so on. The next move on to the final, the formula we can write the x naught integral over the limit x naught to x naught plus nh f of x dx equals to h by 2 y naught plus y1 plus h by 2 y1 plus y2 plus h by 2 yn minus 1 plus yn. Therefore, the integral over the limit x naught to x naught plus nh f of x dx is equal to, look here, each term h is common, h by 2, h by 2, h by 2. Then we can take the h by 2 from all the terms, we get h by 2. The remaining term we write y1 is y naught is combining with yn. These two terms y naught plus yn write together. Why we are writing these together means other terms here 2 is common. These two are, there is no common. So y first term and last term y naught plus y1. Remaining already we have to h by 2 is common. What we have right here 2y1 2 times of y1 plus y2 plus and so on yn minus 1. So this formula is known as the trapezoidal rule for a numerical integration. The trapezoidal rule can be applied to any number of subintervals. Intervals may be odd or even. Then let us see the geometrical meaning of the trapezoidal rule. Look here figure. Here this is the x-axis. This is the coordinate axis actually. Y-axis, x-axis. Here y is equal to f of x means y is a function of x. We are only substituting different values of x. X is equal to x naught, x1, x2, x3. X is equal to x naught will get here. X is equal to x1 here. X1 nothing but x naught plus h. X2 nothing but x1 plus h. X1 is x naught plus h. Then x2 is written as x naught plus 2h. Then that the definite integral over the limit x naught to x n f of x dx represents the area bounded by the curve y is equal to f of x. This is the curve here. Y is equal to f of x curve. Uh, the ordinates x naught, x1 and so on xn on the x-axis. In trapezoidal rule, the curve y equals to f of x replaced by n straight line segment joining the points. Look here, this is the segment x. This is x naught, this is y naught, this point is x naught, y naught. This is x1, y1, x2, y2. In trapezoidal rule, the curve y is equal to f of x is replaced by n straight line segment joining the points x naught, y naught, x1, y1 and x2, y2 and so on. xn minus 1, yn minus 1, xn, yn. The last will get it, this point is xn, yn. Then area we want, this area of this curve we need means we take the perpendiculars from each point. Then these are the points. This is y naught, y1, y2, y3 and so on. Then area is equal to how to find integral over the limit x naught to xn, x naught to xn f of x approximately given by the sum of the areas of the n trapezoidums. Means here we applying the formula n times 1, 2, 3, 4 and so on. This is the n times, and this method is known as the trapezoidal rule. Then next move on to the one more important rule, that is Simpson 1/3 rule. Then substituting n is equals to 2 in general quadrature formula, this is equation 3. In quadrature formula we get Simpson 1/3 rule. We get substituting n is equal to 2 in the quadrature formula equation 3 and neglecting the third and other higher order differences. We consider only two terms. Other higher order we neglect. Then I1 is equals to integral over the limit x naught to x naught plus 2h f of x h 2y naught plus 2 delta y naught plus 1 by 3 1 by 2 8 by 3 minus 2 nebula square y naught. How will get it, this one? In the quadrature formula, in this formula put n is equals to 2 and we consider only two terms only. Then we get in this form I1 is equals to integral over the limit x naught to x naught plus 2h f of x dx h times of 2y naught plus 2 delta y naught plus 1 by 2 8 by 3 minus 2 delta square y naught. So h as it is, 2y naught as it is, so delta y naught can be written as y1 minus y2. Then delta square y naught written as y2 minus 2y1 plus y naught. Now this already we solved here in the earlier classes, a second or third class like this. So take the 3's here, h by 3, then take the 3 common and simplify it. Then what will get it? 3 LCM means 3 is multiplied by each terms of here. That means 6y naught plus 6 times of y1 minus y2. Then here y2 minus 2y1 plus y naught. Then first what you have to do? Y naught 6y naught divided by 3 is there. Then y naught plus 4y1 plus y2 will get it. Similarly, we can find the higher order also, that is n is equal to 3, 4, 5. When n is equals to here, similarly I1 is like this. We write I2 is equals to integral over the limit x naught plus 2h x naught plus 4h. Look here, x naught plus 2h is there, x naught plus 2h, x naught plus 4h is there. We are put n is equal to 4 like this. Then we get h by 3 y2 plus 4y3 plus y4 and so on. When in general we'll get the Actually, this is Simpson 1/3 rule. That is I1, I2 and so on. In is equal to integral over limit x naught plus n minus 1 into h to x naught plus nh f of x dx is equal to h by 3 yn minus 2 plus 4 yn minus 1 plus yn. Hence n is even here. N is substituting only 2, 4, 6 like this. Then this you look here. I1 is h by 3 y0 plus 4 y1 plus y2. I2 is h by 3 y2 plus 4 y3 y4. Observing these two terms, we write the n terms h by 3 yn minus 2 plus 4 yn minus 1 plus yn. Now this is the general formula, we write like this. Adding again these n integrals, then we will get integral over the limit x0 to x0 plus nh f of x dx is equal to h by 3 y0 plus y1 plus 2 times of here we get the even terms, that is 2 times is multiplied by y2, y4 and so on yn minus 2 plus 4 times of y1, y3, y5 and so on plus yn minus 1. This formula is known as the Simpson's 1/3 rule. So next move on to the Simpson 3/8 rule. Put n is equal to 3 in the general quadrature formula. We get, neglecting the all differences above third order, we can neglect it. We consider only up to third order. Then integral over the limit x0 to x0 plus 3h f of x dx is equal to h into, wherever n is there, put 3 in equation 3. In the Cote's quadrature formula, we get 3y0 plus 9 by 2 delta y0 plus 1 by 2 into 9 minus 9 by 2 delta square y0 plus of 81 by 4 minus 27 plus 9 delta cube y0 6. How will get it this one? In the quadrature formula here, put n is equal to 3. N is equal to 3 means h as it is, n is here 3. 3y0 plus 3 square by 2, 9 by 2 delta y0. Again delta y0 you write y1 minus y0. Here 1 by 2, n cube is there, n is 3. 3 cube, 27 by 3 minus 3 square is 9 by 2 and so on like this. Then simplify, we will get this term h is equal to 3y0 plus 9 by 2 delta y0 1 by 2 and so on. Now simplify here, as I told, h as it is, 3y0 as it is, 9 by 2 as it, delta y0 is y1 minus y2, delta square y, then simplify this, then 9 minus 9 by 2, then here take the LCM 2 means it is 18 minus 9, 18 minus 9, 9, then 9 by 4. So y2 minus 2y1 plus y0. This is delta square y0. Delta square y0 is written as delta of delta y0. Delta y0 value is already know that y1 minus y2. Then apply delta y1 minus delta y0. You will get simplified like this, y2 minus 2y1 plus y0. Then again here take the LCM. Here 86 is there, 4 is there. Then we get the 6 4s are 24 and take the simple minus 27 plus 9. It is minus 18, 81 by 4, simplify it, and delta cube y0 you multiply, you get 3 by 8, this constant. Then delta cube y0 is written as delta of delta square y0. Delta square y0 already is there, y2 minus 2y1 plus y0. Then each term is multiplied by delta y2 minus 2 times of delta y1 delta y0 and simplify, we will get this one. We did already theory part in the starting. I will get it all the terms. So simplify the terms, same terms here. Each term 3 is common. Here 3 is there, 9, 9, 3 is there. Take 3 by 8 is common. Then 3 by 8 common means here it is multiplied by what? 8 is LCM. Then 8 3s are 24, why not? Here 12 2s are 24 means what will get it? 9 12s are 108, y1 minus y0 and so on like this will get it. Then after simple mathematics is there, what you have to write means After taking the LCM, we write y1, y0 terms together, y1 terms together, y2 terms, y3 terms. There is some simple mathematics, some addition, subtraction. Then after doing that, we'll get 3h by 8, y0 plus 3y1 plus 3y2 plus y3. Similarly, look here, we are taking here in the Simpson 3/8 rule, only n is equal to 3, n is equal to 6. In the Simpson 1/3 rule, we is taking n is equal to 2, n is equal to 4. So that is why look here, limits x0 plus 3h to x0 plus 6h, f of x dx equals to 3h by 8, y3, 3y4, 3y5, 3y6. How will get it this one? Again, we substitute n is equal to 6, where in the quadrature formula, and using the neglecting the higher order, we consider only up to third terms. How will get it like this? H here 3y, here 6y0, where n is equals to 6 means h into 6y0, 6 square by 2 delta y0, 1 by 2, 6 cube by 3, 6 square by 2 delta square y0 plus 1 by 6, 6 to the power of 4. Like this simplification will get. Then 3 by h, 3h by 8, y3 plus 3y4 plus 3y5 plus y6. So put n is equal to 9. Then integral over the limit x0 to plus 6x to x0 plus 9h, f of x dx, 3h by 8, y6 plus 3y7 plus 3y8 plus 3y8. Then continue like this. We get the general term, integral over the limit x0 to x0 plus n minus 3 into h to x0 plus nh, f of x dx, 3h by 8. Look here. Here the first one means x0 to x0 plus 3h, this term. Observing these two terms, you write the general term. Then 3h by 8, yn minus 3 plus 3yn minus 2 plus 3yn minus 1 plus yn. Adding all these integrals. Then finally we get, adding these integrals, we get integral over the limit x0 to x0 plus nh, f of x dx is equal to 3h by 8, y0 plus yn. Then how to write? First you write these terms, 3h by 8, y0 plus 3y1 plus 3y2 plus y3. Then next plus this term, 3h by 8, y6 plus 3y7 plus 3y8 plus 9. The general term is like this, 3h by 8, yn minus 3 plus 3yn minus 2, 3yn minus yn. So each term contains 3h by 8, 3h by 8, 3h by 8. 3h by 8 we took the common. The remaining, how we can write the terms means, write y0 plus yn, y0 plus yn. Here y0 is there, first term. This y0 you write together this yn. Here the remaining 3, here this is 3y1 is there, 3y2 is there, 3y4, 3y5, 3y7, 3y8, 3yn minus 2, 3yn minus 3. Take these all the terms common, we will get 3 times of y1 plus y2 plus y4 plus y5, yn minus 1. The remaining is here, y6 is there, y6 is there, here y3 is there. Then here 2 times of y3 plus y6 plus and so on, yn minus 3 will get it. This is known as the Simpson 3/8 rule. Now here we know that trapezoidal rule formula, Simpson 1/3 formula, and look here, these are all the important formulas here. Now this is known as 3h by 8 into y0 plus y1 plus 3 times of y1 plus y2 and so on, yn minus 1 plus 2 times of y3 plus y6 and so on, yn minus 3. This is known as the Simpson 3/8 rule. So up to this stage we know that what is the meaning of quadrature formula, trapezoidal rule, Simpson 1/3 rule and Simpson 3/8 rule. Let us we move on to some simple examples on these formulas. So first one, Evaluate integral over the limit 0 to 1 dx divided 1 plus x square using trapezoidal rule, taking h is equal to 1 by 6. Simpson 1/3 rule, taking h is equal to 1 by 6. Simpson's 3/8 rule, taking h is equal to 1 by 6. Here, the given integral, observe it. The integral limits is, lower limit is 0, upper limit is 1. The 0 to 1, we take the subinterval such a way that it is equally parts. So I took here how many parts? 1, 2, 3, 4, 5, 6 parts. Then that is why we took here 1 over 6. Means 1 by 6, 2 by 6, 3 by 6, 4 by 6, 5 by 6, 6 by 6 is 1. So using, then this is the given table. Y of x is equal to, x values are like this. Then y of x value is like this. This is the table. Using this table, we can use the trapezoidal rule or Simpson 1/3 rule, Simpson 3/8 rule. We find the numerical integration of the given value. So here h is equal to 1 by 6. We did the 6 parts equally. Let y is equal to f of x. Here, let y is equal to f of x. F of x is 1 over 1 plus x square. To find the value of f of x for the points of subdivisions are as follows. F of x is equal to 1 by x square. Then put x is equal to 0. We will get 1 here. Then how will get it, this one? Put f of 1 by 6 in the f of x is equal to 1 by x square. F of 1 by 6 is equal to 1 divided 1 plus x square. F of 1 by 6 is equal to 1 divided by 1 plus 6 whole square. Then 1 divided by 1 plus 1 by 6 whole square, 1 by 36. Then take the LCM and take numerator, get 36 by 7. 36 by 7 you write in the decimal form 0.9729. Like this we can substitute x value is 2 by 6. In this we simplify it, we get 0.9. Then 3 by 6 0.8. 4 by 6 0.692. 5 by 6 0.590 and put x is equal to and get 0.5. Here I substituting last value. Here x is equal to 1. 1 divided by 1 plus 1 square. 1 square is 1. 1 by 2. 1 by 2 is half. Half value is 0.5. Now this is the our main actually table. Now look here, we only construct this table. Table is not given. So only using this equation we are finding the table also. In the exam the question will come like this only. Using the Simpson 1/3 rule or Simpson's 3/8 rule or trapezoidal rule to find the integral value. That's all. So first we write by trapezoidal rule. This is the rule, integral over 0 to 1, because our limit is 0 to 1. Here our given problem is 0 to 1. Then integral over 0 to 1, 1 to 1 plus x square dx, h by 2, y0 plus y6 plus 2 times of y1, y2, y3, y4, y5. Now this is the formula. We have already proved also in the. Then h is here 1 over 6. H is 1 by 6. Then 1 by 2 as it is. Y0 value. Now this is here y0 value. This is y1 value, y2 value, y3, y4, y5, y6. These are all the y values. Substitute here. Y0 is 1. Then y6 is 0.5. 2 times of. Y1 is 0.9729. Y2 is 0.9. Y3 is 0.8. Y4 I taking from the table. Y4 is 0.692. Y5 is 0.59. So simplify this one. A simple mathematics is there and add all the, divide by 1 by 12, get 0.784. Then using the Simpson 1/3 rule. This is the rule. Integral over the limit 0 to 1 dx divided by 1 plus x square. I using the same problem, all the three different formulas, trapezoidal rule, Simpson 1/3 rule and Simpson's 3/8 rule. Then h by 3. H is 1 by 6. Then what is the difference between these two means here? Here 2 is common. Y1, Y2, Y3 come. Y0 plus Y6. But here not like this. Even terms multiplied with 2, odd terms multiplied by 4 in Simpson one-third rule. I am telling you once again, the first term and last term as it is. When next terms I will get it means even terms, all the even terms multiplied by 2 and all the odd terms multiplied by 4. So 1 by h is 1 by 6 here, then 1 by 3, y0 is again using the table only, y0 is 1, y6 is 0.5, 2 as it is, y2 value is 0.9, I am using the table there, y4 is 0.692, 4 as it is, y1 value is 0.9729, y3 value, y5 value. Simplify this. Like this Simpson 3/8 rule. Simpson 3/8 rule also, the rule is like this: 3h by 8, y0 plus y6, 3 times of y1, y2, y4, y4 plus 2 y3. So h is here 1 by 6. Then 3 by 8 as it is, h is equal to 1 by 6. How will get it? From the given problem. y0 is 1 value, y6 is 0.5, 3 as it is, y2 is 0.972. This is also all the values you will get from the table what we have constructed, that using the f of x is equal to 1 by x square, and simplify it, we will get 0.7849. Now this is also one problem. Evaluate integral 0 to x dx to 1 plus x square by using trapezoidal rule, Simpson one-third rule and Simpson 3/8 rule. Divide the interval 0 to 6 into 6 equal parts, that is h is equal to 1. So that is h is equal to 1 means here x is equal to 0, 1, 2, 3, 4 up to 6 here, 0 to 6. So f of x is 1 by x square. Then put x is equal to 0 here, we will get 1. Put x is equal to 1, you will get 0.5. Put x is equal to 2 here, you will get f of 2 value. F of 2 value nothing but y2 value 0.2, and so on, will get the table. From this table, these are all the x values, and below values are y values, y0, y1, y2, y3 up to will here y6 values. Using the trapezoidal rule, as you know that in the previous example, integral over 0 to x, in the previous example our limit is 0 to 1, here 0 to 6 is there. This is very important. How to the interval is equally spaced, then it is very easy for us. Then integral over 0 to 6 dx to 1 plus x square h by 2 y0 plus y6 plus 2 times of, this is formula, and 1 by 2 h is here. What is h here? H is here 1. H is 1. So 1 by 2, y0 is here, y0 is 1, y6 is 0.07 substitute plus 2 as it is, y1 value 0.5, y2 value 0.2, y3 value is 0.1, y4 value is 0.0588, y5 value is 0.0385. Simplify this, we will get 1.4108. And Simpson one-third rule, they are using the same values, and integral 0 to 6 dx divided plus x square h by 3. This is the formula. Again this formula, substitute the values of y0 to y6. Then 1 by 3, y0 value is 1, y6 value is 0.07, 4 as it is, y1, y3, y5, substitute values, 2 times of here, y2 plus y4, substitute the value, simplify it. Then Simpson one-third rule also use the same values, and simplify, you get 1 plus 3, 5, 7, 1. Look here, then come to the conclusion, we are using the same problem. In trapezoidal rule, you get 1.4108. In the Simpson one-third rule, 1.36602, 1.357. Which is the better one means the lesser error, means lesser error we get from the Simpson 3/8 rule. Then this is the modified. Compared to these two results, trapezoidal rule as well as the Simpson one-third rule, Simpson 3/8 rule is the accuracy is more. So this is one example. This is one example. We can solve the as above discussed. One more problem. Find the value of integral 1 to 5. This is different one. Here log 10 to the base x is there. and taking the 8 subintervals, correct 4 to decimal places by trapezoidal rule only. In the previous we have studied two examples, trapezoidal rule, Simpson 1/3 rule, Simpson 3/8 rule, but here only trapezoidal rule. Then h is equal to 5 minus 1 by 8, 5 minus 1 by 8 because 8 subintervals. Then 4 by 8, 0.5. H is 0.5 means 1, 1.5, 2.0 and so on 5.0. From this log values, f of x is a logarithm of x to the base 10. If substitute x is equal to 1 here, what will get it? Log 1 value 0. Then it is 0. Here see very carefully, logarithm of 10 to the base x is different. Logarithm of base e to the b e to the logarithm of base e to the x is different. Don't consider both are same only because base e is different, base 10 is different logarithmic. Here we are using the logarithmic 10 base. So use the logarithmic 10 base, then we'll get 1.5 is like this, 0.17609, 2.0 value get it like this. These are all y1 to y10 value. Then using the trapezoidal rule. Trapezoidal rule is our, here limits is integral 1 to 5. Logarithm of x to the base 10 is equal to h by 2 y0 plus y8 plus 2 times of y1, y2 and so on, y3 and so on. These are all the formula will get. H is 0.5 here by 2 as it is, y0 value is 0, y8 value is here 0.69897 substitute plus 2 times of y1 value is 0.17609 plus y2 value is 0.3013, y4 value is 0.39794 and 0.47712 is y4 value. This is y5 value, y6, y7 values. And simplify will get the trapezoidal rule logarithmic base 10 is 1.7505025. Now these are the some examples from the textbook. Try to solve these all. Okay. We meet in the next class. This is your last class. After this class your syllabus is completed. If you need revision, we can take the revision classes. Okay. See you next.